So I left off in the last video that we were going to move on to example 3. Because of the time, I decided to break it up. So this is the second part to the vector representation using algebraic notation. So feel free to start off with that video and come on to this one because we went through a bunch of different operations. Do not just jump into the second video without watching the first. Alrighty, so we'll take it from there. Alrighty, now for this next one, it's a bit of a doozy to start off with, so please walk through with me when I show you. This one states that A is point, this is a coordinate, 0, 4, so it's not a vector, and B, point B, is 6, 1. Find the coordinates of P, another point along this AB path. That is 2/3 along the way from A to B. So we're going to take a moment and try to draw this out, but I want to use some analogies along the way. So let's draw our coordinate system. We're going to use our grid here to draw this out. And I'm going to say my tick marks, 1, 2, let's do more evenly spaced. 1, 2, 3, 4, 5, 6, 7. I'm just drawing them. This is not a big deal. So 0, 4, let's use this as my point A. A is 0, 4, and B is 6, 1. 1, 2, 3, 4, 5, 6, and 1. So this is B, and this is 6, 1. So AB is going to be this vector, and I'll just use blue to draw this. It's from a straight line, or as straight as possible, and this is going to be vector AB. We need to find some point P, and I'm going to do this in red. Point P is some point along here, okay, and we don't know where that is yet. I'm actually going to draw it a little bit larger, so in case I need to erase it, or I won't erase the whole thing. Yeah, I'm just going to say it's along AB, so I'll use a pointer tool. So it's somewhere along this point, 2/3 along the way. Probably 2/3 is going to be around here, I assume, but we need the exact measurement of this coordinate. So how do we do this? On this screen, I'm going to show you how I would consider this idea. So just quickly coordinate grid. Let's say you are here. We're going to draw you in blue, right? You're doing a race, okay? This is your origin, okay? This is your home base. And I'm going to draw like a little model here. This is going to represent your house, all right? This is not a good house. Okay, this is what I get for drawing it really quickly. But you're at home base, this is your origin, your point A. Now let's say you decided to do a 5K. So I'm going to put a little running neon shirt on this person. Now, they decide to run, but if they want to run, let's say, again, our point A was here, approximately, and our point B was here. That was a little higher up, right? Point B was here. Let's say that was the 5K race. Well, if you're doing the 5K race, you don't start from here. You don't start at home. No. You have to go from here all the way to A. And now you might get a warm-up by trying to run to A first and then do your race, but you want to get to the starting position. So let's label this the starting position. A is starting position. And this is your ending position. So this is where you have your flag, your checkered flag at the end. Let's just do this and draw a little diagram really quick. Checkered flag. I don't know if I can do it well here. Okay, use your imagination. So this is the ending, okay? And if this is your starting position here, and you're running this straight line from A to B, okay, let's try to draw that straight line, okay, if you want to find 2/3 of the way there, okay, you would want to use this measurement AB, right, if it was a fixed distance. But this AB is a vector in this case. This is a vector position. It can be anywhere. It can be any measure. Now, for this vector, if we were trying to measure 2/3 of the way there, we actually need some other reference point. So what we're actually going to do here is we're going to use our reference point of home base right here, and try to measure where this point is. We're going to be using This, we call this O, and this is P. So we're using OP as our vector to locate this position P, X, Y. So how do we do that? Well, if you actually notice here, we can actually do this simply by taking this OP vector with another vector which we already have drawn, which is A, the A vector. Okay? We can take that vector and this vector together, and we get this vector here. Or sorry, the position here along these path. Okay? So use this as reference, please copy that down, and let's go back to our initial setup. Okay, so let's find that point P. So point P is going to be around this area here. Okay, I'm going to draw it in now, and I'm probably going to end up erasing it, but I'm going to draw it in now and say this is point P. It's probably not that far down. I'll just put it here. Looks better. So to find point P, we actually have this relationship we can set up, saying we're going to use the vector OP. Remember, this is O, and so this is the vector OP. To find this vector OP, we need OA, so we need this vector here, going from your house to the starting position, so OA. And we actually have I think a very nice way of looking at this is by saying to find this new vector AP, and I'll do this in a different color entirely. Let's do this one here. Yep, that works well. That this is going to be AP. To find AP here, we can just simply say it's 2/3 of AB. So AP is equal to 2/3 of AB, vector AB. I actually love to look at this idea here, this 2/3, as being time. How far in the race are you? So I'm going to rewrite this and say that this is OP is equal to vector OA plus 2/3 of AB, vector AB. Let me do that in blue to continue our references. So we have 2/3 of AB. So this part actually, I think this is very easy to understand, this bit. The time here, or the fractional amount of the vector AB. It's just this OA here is just the starting position we have to add on to see how far we are in the race. Because we can't do it from the origin. Because if we did it from the origin, that's like doing it from our house. We can't consider that as like, hey, how far along in the race are you? If you're 2/3 of the way there, okay, well, if I'm looking at your position vector, well, I have to do, where's my starting position? It's not your house. So we have to add that in. And that's adding this vector in here. So let's keep going. And let's just plug these in. Vector OA is simply going to be 0, 4 because the difference is 0 minus 0 and 4 minus 0. So you're going to get 0, 4 for here plus 2/3. And the vector AB, that's going to be the difference of 6 minus 0. And it's going to be, move that over here. Sorry, that had a little thing pop up, and it's going to be 1 minus 4. So you're going to get, I'll rewrite it again, 0, 4 plus 2/3, 6 minus 3. Now we actually do our scalar multiplication here, and we end up getting 0, 4 plus, this is going to be 12 divided by 3, this is going to be 4, and this is going to be negative, we have to include that negative. This is going to be negative 2 because the 3's cancel out. So you get this amount, and then we add them together. You get 4, 2. So 4, 2 is your position. Oh my God, I'm actually really close with that. I promise I didn't plan it that way. We actually have, is it 4 up, 4 across, and 2 up from it. Yeah, that's our position P. Would you look at that? Perfect. Now, if you're trying to say, hey, I could just guesstimate that in the future, I don't need any of this work. No, you need to prove it, okay? So make sure you understand this. If you have any questions on it, make sure you write down anything you are concerned about, any misconceptions, and we can review it together in class when I see you all next time. So I hope you enjoyed this video. I actually really like this topic. This is actually has a special name. a special name for it, and it's called your vector equation without the component form. We'll show that in the next video. Okay, we're going to show this in component form, and that this is going to be our direction vector. So, hope to see you all next time. Take care.